All right, what's up, everyone? Week 115, building my own operating system. Thank you very much for joining. I'm pretty excited for this stream. We're going to be getting into some meaty topics back into the core of the scheduler. Things like, for example, a big topic last time was how do we destroy the task stack in a clean way at the very end of a task lifetime. So I'm excited to get into that. And before we do that, I very much want to thank our sponsor of the stream. Thank you to Let's Get Rusty for sponsoring today's stream. If you're watching this, you've probably heard of Rust. Rust is a systems language with modern tooling and safety guarantees. It's actively used by companies like Amazon, Microsoft, and Google. If you've been thinking about learning Rust, Let's Get Rusty is the go-to place for both personal and corporate Rust training. They've helped thousands of developers learn Rust and also assist with job placement. They're running a new cohort next month. Spots are limited, so now's a great time to check it out. Visit letsgetrusty.com/startwithmark to find out more. There's a link below also. So yeah, big shout out to Let's Get Rusty. All right, and with that said, let's get into today's stream. What's up, Bet Kitty? Nice to see you. Thanks for popping in the chat. I'll hit it with the test 0 as usual, just to check that the widget is working. And we can get into things. All right, ping in the Discord. Nice. Yeah, I'm pretty excited. I think this will be a pretty good day. Just making sure the tweet went out correctly as usual. Looks all right. Okay. What's up, Nirada? Hello, hello. Feel free to post a little check-in in the chat for everyone joining the chat right now. Okay. Nice. Well, yeah, I was doing a bit of prep work, so we got a couple of topics lined up for today. It is April 12th. Yep. Cool. So I want to start off with a scheduler cleanup. And so, oh, I wonder what was building. Let me make a plan. So first thing today is going to clean up task construction and preparation of the landing pad stack area. That's gonna be task number 1 for today, I think. Then this is gonna be second task once we get into that. Yo, what's up one? What's up one Dahaka or Idahaka? What's up? I want to learn to code low-level stuff. Absolutely, absolutely. I'm gonna link you to my resources page in a moment, which is a bunch of links. I'm actually working on my own course for people that are interested in learning from me specifically. I'm working on my own course, and I had to invite you to sign up to my newsletter if you're curious to hear about that. So let's jump into the code. Well, first of all, let's just run the OS and see what's going on. So we're in a state where it is just running the idle task a lot. So nothing too particularly interesting Got the test 0, and the test 0 is just calling, it just exits, and then we just run the idle task a lot. So that's what we were doing. I know Java, what do you recommend me to start with? I mean, for low-level programming, you want to learn C. I think C is a good foundation to learn, and there's some links to some courses for C in that resources page. Harvard CS61 is a pretty good one from the looks of it. That's where I would start with. Right, so that was our current state. And what I want to talk about is, I want to talk about cleaning up a little bit of the APIs around the scheduler. Yeah, no problem. Daka thinking about learning Rust. Nice one. I want to learn Rust also. Yeah. Try to help Cosmic DE. Yeah. It's a desktop environment, I guess. I'm not so familiar with it, but yeah. If you didn't see the intro shout out, Let's Get Rusty offers Rust training. You can use my link, start with Mark, to get into Rust development. If you want some help and guidance around that. But yeah, eventually I plan to learn Rust at some point also, absolutely. So let's talk about this part of the code. So what we're doing is we're in the create task API. And this is all about kind of allocating a new task, constructing it into its initial state so that it can be run by the scheduler at a later point in time. And the task looks like this. It's a pretty simple struct right now. Task ID, some scheduler state, register state, pointer to a task stack. And that's sort of what we're doing over here. We're constructing a new task, but there's also some initialization work that we need to do around the stack. So in particular, I want to protect against cases where a task kind of falls off the end. Basically, a task is a function, and typically tasks need to end by calling the task exit API. But in case a task accidentally falls off the end, I want to prepare the stack in such a way where it automatically is handled gracefully in some kind of way, as opposed to just sort of like crashing in a weird way. And that's where this notion of the landing pad comes in. And so I'm preparing my stack in such a way where it automatically triggers the landing pad if the task finishes. NSG, what is up? Nice to see you. Oh, how like Windows does it. Okay, NSG is a Windows expert. I have no idea how Windows works. This was just my thoughts. I would be very curious, NSG, to hear how you are doing things, but just the basic motivation is I will eventually just be having these kernel tasks that are just sort of these just functions, and in case I forget to call task exit at the very end and it just falls off the end, I want that case to be handled gracefully. I'm curious how you handle this. I am inserting this landing pad and preparing the stack in a particular way. And Windows 2 puts a return address to X function. Yeah. Okay, cool. So Windows does it the same way, apparently. I mean, it makes sense. Polaris doesn't do anything at all. Word. Okay, you just sort of go raw with it. Yeah, and so I have my task exit landing pad. And this thing gets execution. I'm actually just going to introduce a panic just to illustrate what happens. And so I'm panicking with like this, maybe let's say a landing pad to make it more clear. And currently the kernel is just configured to run a test 0 task. All it does is it exits. So let's just add a return, right? So we're not going to execute any of this code in the function. We're just going to immediately return, and that's going to cause the landing pad to execute. And in this version, as I've done it, it's going to panic. So that's what we're seeing. Hello code, what is up? Nice to see you. We're hitting the landing pad, and that is what happens. It is actually calling. It's sort of like automatically calling task exit for you. And I'm actually not super sure I want to keep it that way, because I had this one case in a couple of streams ago where I had the idle task and I forgot to have a loop in it or something, and so it like accidentally just fell off the end, and it was actually it caused a very confusing behavior to me, because it then sort of entered the scheduler again, and I wasn't expecting that. So I'm actually considering just simply asserting here, actually. But that's a detail that's not critical to what I want to talk about. I want to talk about a little bit of software engineering right now. So I have an implementation. It does work, and this is what it looks like right now. In the create task API, I allocate a task stack from the pool of task stacks. And then, okay, this is not super relevant. I'm unmapping the guard page because we have this guard page now. Yeah, that is technically something that does need to be done, but that's even a bit of a separate thing. But then the important part is right here. I need to, in order to make this landing pad thing work, I need to prepare the stack in a very particular way. But here's our classic stack. Let's say here's memory, here's our stack, and here's our kind of fresh stack. What I need to do is I need to make sure I populate a return address right here. Landing pad ret adder right here at the very top of the stack. Then I need to make sure, where's my shapes? I want the, dang, I think Miro changed things up right now. So I want the big arrow. Okay, Miro updated in its. Then we need to make sure that RSP, the stack pointer, points here on entry to the task. So that's the setup. What's up, Yosef? Have you written the bootloader in C++? I was thinking the bootloader must be written in assembly. I did not write, no, I'm using a third-party bootloader that I did not write. And it's written in C and assembly. VA80, what is up? 10 minutes late. Good to see you anyway, despite the lateness. What's up? What's up, CT Pong? Project looks amazing. Thank you very much. It has a long way to go, but we got some progress. All right, so this is sort of the situation we're trying to set up, and that's the way my code looks currently. I'm getting a pointer to the landing pad function. That's the thing we're placing a pointer right here. We're like writing a pointer into memory right here. And so I'm getting a pointer to the landing pad. I'm computing the stack pointer on task entry as stack top minus the size of the pointer. And so that's this thing. We're getting that. And then we're doing a write into memory. We're writing the p landing pad func into memory right here. And this works. And then we're going ahead and constructing the task state, and critically, we're pointing RSP to be the stack pointer on task entry. And what I wanted to say here is that this code works, but I think one thing that's important to do for people that want to have a bit more professionalism in their software is to ask themselves, okay, can we do better? because there's a lot of different ways to implement software, and some ways are better and worse than others. And so I think it's always a good question, even if something is working, to ask, can we do better? The soup is yummy. Why mix C cast with C++ cast? Great question. The answer is laziness. It is simply because I was too lazy to type out reinterpret cast. That's the only reason. In production, when I'm preparing this code to like be really merged into the main branch, I would convert it to reinterpret cast. Good question, great question. That is just personally a bit of sloppiness in my current development state right at the moment. And then, yeah, we can clean that up later. What I want to do is I want to experiment. So the question is, can we do better in terms of our implementation? And I have one way that I think that we can do this better. And so the problem is that we're doing setup for the task in two places. We're like constructing the task here that creates the task, but also this code that's running is conceptually part of the process of creating a new task also. And it is just sort of ad hoc code that runs beforehand. But what I want to experiment with is trying to move this more into a centralized place, and specifically using a C++ constructor on the task, which we don't currently have that. And I don't actually know how that will look, but I want to do that right now. So that'll be the first thing we do. So let's check it out. So basically what is going to happen is I think we're going to do a few things. And so first of all, we need to go to our task definition, our structure task. Currently, our structure task is so simple. It's so nice and it's just so simple. And we're going to make it a little bit more complex, ever so slightly, just by moving some code from here, like over into the left side. So yeah, let's do that. And so to start off with, I want to just think about what happens. I think I'm going to ignore the guard page for the moment. That's sort of a separate setup. Let's just focus completely on the landing pad. What I want to do is I want to basically just move this memory right into a constructor. And I still am figuring out exactly how this is going to work. So we're going to need to take a constructor then that takes some arguments. And so we're going to take a size t, task ID. We're going to take arguments that has already been 20 minutes. All right, cool. Feel free to join me for a quick 20-minute stand up and stretch. I'll be right back. Right, so my constructor is going to basically take all these arguments that we're currently receiving, and yeah, we're going to take the ptask stack. Good. Okay, and I'm going to snooze inline suggestions for 5 minutes so I can type this out. So we got our constructor going, and yeah, and so then we're just going to task ID. I'm gonna wait. How do I enable? Sorry, that we were still in a bit of the grunt work that stop. Okay. Okay. Task ID. Okay, cool. So this is just the grunt work of forwarding these arguments into the construction of the members. And now I'm going to snooze it for 5 minutes. So now what I want to do is I want to just basically move this code into here. And let's think a little bit about that. So now what we're doing is, instead of just doing that setup code a little bit ad hoc, like outside, we're just going to formalize that setup really into the task itself. So the task totally knows about its own setup, and any client that's making a task can get a, yeah. Oh man, we got the Streamlabs bot chimed in. I enabled a bit more protections because someone said a slur last week in the chat, which was bad. So I apologize if that was a false positive on the long messages. But that, yeah, like last week, that was like not very good. So I apologize that. Yeah, I mean, yeah, that was bad. Right. So just a simple code movement. We need to include, I guess, yeah. Task exit landing pad. Oh, interesting. So now we need to have this function needs to be available. And again, the default just easy way to fix this is to include scheduler into this file, but that's actually bad. Because that is introducing a dependency from tasks on scheduler.hpp. We don't want to have that dependency in that direction. The scheduler can depend on tasks, but the task is just sort of like this container that shouldn't really know in the message. Yeah, sorry, Mosa. I'm sorry if it was too long. Maybe you can try reposting your thing a little bit shorter, I guess. Yeah, I still need to work on the moderation a little bit about that. Maybe that was a bit too tight. My apologies. So what I'm going to do, I'm just going to move this up here for the moment. It's an inline function. Interesting. Yeah, then technically this needs the kernel, but I think I'm going to just remove that for the moment. I'm just going to quickly rename this so to move forward. So landing pad. Right. Do I recommend the book OS 3 Easy Pieces? I haven't read it, to be honest, so I can't really comment on it too well. I've heard it. Other people say things about it. I actually haven't read it, so I don't quite know. Okay, so now we got now we're at ptask stack top. So this was a local variable right here. Which is just, we can I'm gonna copy all of this in actually. And this thing, okay, we can add, for the moment we can add logging. Okay. So, right, so now we're taking, it's now the task, as part of its construction, it gets the task stack, it computes the task's stack top. We'll handle the garbage page later, and we're populating the landing pad, and that's pretty much it. And then the last thing we need to do is, in this scope, we no longer have this variable task stack pointer on task entry, because that thing is sort of over here now. And so all we need to do is now we need to just go and set register state.rsp equals stack pointer on task entry. And we're going to and we need the cast, and I will be a little bit lazy and use the C64. Oh my gosh, that's embarrassing. And what is, okay, the const. So one issue we're running into is there is a bit of shadowing going on, which is sort of why I like to use these the M prefix on members of structs. I mean, I haven't done this because this was a very simple struct, and things are kind of public there. But anyway, this shadowing thing. Anyway, that's pretty much. And then now that we can do that, we can go ahead and remove this line over here. So we're no longer directly setting RSP as part of constructing our task. RSP gets set internally by the task after it has computed its stack pointer after the landing pad. So that is that. And so I think for the moment we will just sort of ignore this. So now this thing, these are all just unused. I'm just going to comment this out. This is all just unused, and we should be able to build. And right. Okay. Now the compiler is warning us that I have added a constructor here. And now this is really the way you create tasks. And it's saying, watch out, the idle task was not initialized. And that's actually a great catch. And so little task we need, and this is going to help clean some things up, I think. So in the sketched out version, I had this function called init task, which contained a lot of copy pasted code from the create task function. It's like all the same stuff. I copied and pasted it, and that there was always the intention to sort of clean that situation up. And so the cool thing now is the way we can clean this up. I think this should look pretty nice. Instead of running code here, we're just going to check where midle task is. It is, I'm just going to open a split. So let's pop scheduler back over here. And so it's just going to be right here. And so now we're going to construct our idle task. And this thing has generated a bunch of stuff, and I think it's totally right. How do I accept that? So now this is how, okay. Wait, it had suggested something that was quite right. Okay, this is the start of it, but we need to then also do this, yes. Wait a second, sorry, what? So this thing needs to be here. What is going on? Why, what? Sorry, what? Oh, okay, Yeah, here it is. I think this is what we need, yes. So instead of running this function that like mutates the idle task that was like already there, we're just we're constructing it pretty much just all like inline right here. And now we get to reuse the code. We don't need to copy and paste it anymore. Now the code gets all reused in the constructor of the task. So that's a benefit. In general, people call this moving away from mutation and moving more towards immutability. We're no longer constructing an idle task and then mutating it in the constructor to set it into the state. We're just simply constructing the task into the state we want. And let's just double check the diff just to make sure it all looks right. So formerly, we were calling this function that takes a task, takes a func in a context. We were passing in the idle task and then this as, okay, and so actually there was a slight bug. This thing needs to be this to match how we're constructing it right here. But we're passing in this as the context pointer. Because we know for the idle task, we want to pass in this scheduler reference to it. So that's how all of this looks now. And so we can like delete that function. I want to check now if it's building. So now we're building. And now what happened? So now here's the question: what should happen if we run the kernel right now? The kernel is still configured to run test 0. Test 0 is going to return and hit the landing pad, which is going to panic. So let's just sanity test that is working. Task hit the landing pad. Okay, so that is what we expected. Let's take it one step further. And so, or maybe we can even just get a backtrace quickly just to confirm things. So we can see here that we're in X task exit landing pad. That's that kind of new thing that I added in task to HPP, just for the purposes of getting this working. But we're in that call stack where we hit the landing pad. So I see the bot moderated someone's message again. Let me take a moment to see if I can change things. That is getting a little bit annoying. I mean, I don't know. I didn't see the message, so I don't know if it was some hate speech or whatever it was, but it seems like the bot might be a little bit too aggressive right now. Okay, I have nominally disabled that thing. Can someone try to send a long message and we can test it that it was received? I don't know if the bot updates in real time like that, but okay. What's up, internet is trash. I will get to this. Let me re-enable this, but I'll massively increase the limit on the allowed message settings. What would you suggest a guy, CS grad, have 2-year gap on resume after grad and want to build profile into tech and get a job in 6 months? I think in this situation, you want to have some projects. You want to have some projects, I think. Even if you don't have job experience or have a gap, you want to show that you've been working on stuff, you've been grinding on stuff, you've been learning and applying your knowledge. And also contribute to open source if you can. I think open source is a great way to get a little bit of that credibility that you can kind of get from a job, but get it in a way that doesn't have such high barriers necessarily. So I think that's what I would recommend. Thanks for the question. Cool. So that's working. Let's move it a bit faster. So now let's go over here. Let's get rid of these other tasks. And so we have a single task, test 0. What I want to see is that the idle task is still running correctly. In fact, let's just even remove all of the tasks. And now let's just observe that the idle task runs. And the idle task looks like this. It's a very simple thing that just prints out idle task running. So let's just run it like that. So idle task is running, so that's good. So that means I didn't totally break the idle task with this refactor, so that's good. And I think now I can more like kind of finalize things, and that's going to look like coming over here. I'm going to remove the X. I'm going to come over here. I'm going to delete this. I'm going to delete this. And I want to replace this with a panic that says okay, actually what I might do, I kind of want to print out the current task ID. So here's what I'm going to do. I wonder if I can move this into, move function body out of line. No, add declaration in this file. Okay. This is not exactly what I wanted, but I wanted to just move this into the C++, oh, we don't have a C++ file. Okay. Duplicate. Task.c++. Include task.hpp. Good. Okay, cool. And now I can include kernel.hpp. And now I can scheduler current task. Okay, so now I can do something like task exit, like hit landing pad or something like that. I need a cert. Sorry. Does that help? The kernel symbol is in kernel.hpp. Panic is in assert.hpp. What? And then I guess cmake current. I need to scheduler.task. What happens with the build? Okay, so I need to fix this up. It's on too many. Oh, interesting. I am... Panic accepts a single argument, and I'm trying to string interpolate a little bit. How? That's a good question. Okay, I'm gonna have the AI help me. So how? Please find out how to use rig to I don't know, create a string to pass to panic. I mean, really, to be honest, this like doesn't totally matter so much for the actual current moment. I can just remove that. All right, what's up, Tubra? Nice to see you, my guy. It's been a minute. How would you suggest to build a knowledge base to contribute to complex open source projects instead of easy one? I think you need to start out with things that are approachable for you. And so I would say just find your interests, find some projects that seem interesting to you. Or I mean, you don't have to do that. You can also just work on your own projects, but you need to be building stuff. I think that's important to show. Okay, so that refactor got a little bit chaotic. So the idea, going to drop this. I don't know what that is. Getting rid of all this stuff. So this could maybe have been done in a little bit more of a graceful. Okay, I don't want to commit that stuff. So this is just sort of, so I'm going to call it whip construct landing pad in task ctor. We've hit the second break. I'll be back in 20 seconds. Feel free to join me. So wiser divisor. How is new kernel going to be different from Linux kernel? Be using the same tricks? No. I mean, I don't really want to do things like Linux. I'm not really interested in POSIX compliance. I'm not really interested in a lot of ways they do things. Mine will be a lot smaller, of course. I'm using C++ as an implementation language for starters. So yeah, I'm not trying to compete with Linux or anything like that. So I think so. So what's the deal with this? So how to interpolate a string. We can race it. And so the way, how does this work? Let's check out logging.hpp. The way my logging works, I use frig format for the logging. And would you also want it to run on very low power hardware like the ESP32? That's not currently a goal. I'm just doing things very boring right now. I'm just targeting Intel processors, Intel 64, x86 64. So I'm not trying to overwhelm myself with like all these different requirements to make it so novel and to make it run on tiny things and whatever. I'm just doing a very just kind of boring basic approach, but using like C++ and some more modern tech. Oh, string format. That's the one. And so, string format returns an ETL string. So let's, yeah, so that would be the idea. I have these functions string format, which, is this an implementation detail? Yes, this is the implementation detail. Which could maybe even be in a detail namespace, because this is really the API. So I'm just gonna say, or inline, move this to inside detail namespace. We can use the string format routine to return to format an arbitrary string. And it did not. I think this inline chat thing is like kind of stupid sometimes. It doesn't really. I mean. Oh wait, okay, never mind. I think I was misreading this. This is not an implementation detail. This is a function that formats into an existing ETL string, as opposed to a function that constructs and returns a new string. I see. Let's go with this one, string format. So the way that this is going to work is, I mean, for the moment, we can just do something like this, and auto stir equals, okay, and it sort of knows what we want to do. Why? Okay, task. Or no, well, yeah, that actually, yeah, entirely, it's like stir dot c string. And we need to include string format dot h, and then now we have a sort of like a formatted panic string. There's probably a better API. We could probably move that directly into the macro somehow. For the moment, I mean, this is even too long. I don't really know how long how many characters this is. Does the editor say somehow? But 25 bytes. Okay, we'll call it 32. So now let's test this out. And so let's make something hit the landing pad now. Kernel.cpp. We're going to call test 0. We're going to make this hit the landing pad with the return, and we should see that it doesn't compile. Whoa. What is up? Okay, not gonna lie, this error message is impossible to read. And so far removed from what we are trying to do here. Let me look more closely. So obviously the problem is from this, right? No. What? What? Task. Is even including string format a problem? Oh wow, something got really broken about just even including string format. Huh, that's interesting. And yeah. That's kind of whack. What could it be? All right, I'm gonna whip out Cloud Code to help me with that, because try to build with, make, and diagnose the problem. Ismail, what is up? Good to see you. Ugh. Console logging stuff. I got a little distracted. We were working on its scheduler stuff, setting up the task state, this landing pad concept, and I got a little bit distracted with trying to make a nice panic message where, in case a task sort of falls off the end, it prints out a nice formatted message. ETL headers contain long double specializations. Apparently ETL string. Okay, ETL string is apparently a type that I have not used in the whole time after the 64-bit port. And apparently I'm only seeing this now, because I remember I did get ETL strings working back on 32-bit. But define ETL, no long double support. Hopefully we can just do this kind of quickly. So let's just see. What is the terminal? This thing right now, I'm using Ghosty terminal. ETL no long double support. Let's just check this out. Same as ETL pipeline in data engineering? I don't think so. No, this is very different. This is the embedded template library, which is a C++ library designed for use in embedded freestanding environments. And part of my idea here is to try to use it as a component in building my operating system, as opposed to rolling all of this stuff myself. Okay. This is not really exciting. I sort of don't know what I'm doing. So, wow, okay. Can I just hack? I'm just going to try to hack the hell out of this thing to try to get it to pass. I'm just going to add a random C flag. Long double 64. truly, who even knows what that, okay, nothing has worked. So I'm going to make an executive decision to no longer try to pursue this very uninteresting thing right now. Task on CPP is where we were. We're just going to go ahead with a simple. Did you try to cloud builds, make no mistakes? I did not yet, but I got more important things to do today, so we can defer that to later. I mean, on second thought, we can just shoot it out. I'll just say I did everything you told me to. Okay. I did all that. Still not working. What's the problem? Okay. Which will give us a moment to think about this. So, backtracking to what we were originally working on. We were working on adding some good software engineering to our task struct, and moving the responsibility of setting up the landing pad from outside external code in the scheduler really into the actual task constructor. And that seems to be working pretty well. Okay. I'm just gonna let it do its thing. And globally, that I already did this in third party ETL-C make list.txt. Oh, what? Components for defines. Patch ETL. So that's interesting. Yeah, that's a bit unfortunate. I think what I'm finding with ETL is it's a good library, but there are definitely some issues I'm running into with integrating it into my OS build. I am really enjoying it for use with like its data structures, like the list and the pool, and I'm currently using those in the scheduler. But there are some of these rough spots, and so that's interesting. Okay, please try one. So I'm just gonna have it go ahead and patch ETL because I've been doing that pretty liberally if needed. Did God tell you to make an OS? I'm not sure. Not that I know. Build succeeds. Okay, so apparently a patch was needed, so but apparently let's just try this. So let's run it up. Task 0, hit landing pad. Yep. All right, cool. So we got, yeah, it is very useful. I think, yeah, it is a shame that it's not just completely working out of the box, but really, like, as far as I know, I'm the only person that's using it to do OS development. And so I'm sort of the first one to hit a lot of these issues. But overall, I think the benefits are outweighing the downsides. So to make a better macro API. Nice. Now let's talk about the v-address space unmap for the guard page. So sort of I mean, this doesn't necessarily have to be like a big complex thing. We could just simply pass in okay, we just pass in the address space that we have here. So we pass in the MV address space. We can, interesting, we can take the address space, and then over here we can use it. So Sandesh, prerequisite before setting up or getting started to build an OS. I think really just like knowledge-wise, you should probably know C pretty well. Otherwise, you can just sort of get going with a lot of that coursework that's out there. So, yeah. The problem is you didn't start with writing your own bootloader. I don't know if that's trolling, but if it's trolling, I agree. Okay, so here's what we're doing. So as part of the tasks construction of itself, it's not only setting its register state, but it's also tweaking its stack setup a little bit. It's setting the landing pad, it's pointing RSP at the correct place, and it is unmapping the guard page. So, of course, it's a joke. You can never be sure these days. People got crazy opinions on the internet these days. People be saying wild stuff like you need to write a bootloader to write an operating system. Absolutely unhinged opinions are being expressed on the internet about this kind of thing. So let's verify that this is working. So again, this is just like code movement for the most part, but let's look at tasks. So here we got our task 0. What we're going to do is dereferenced guard page successfully. Something is wrong. That's good. That's a good message. And so what we're going to do is I'm going to go back over here. I'm going to enable test 0, and test 0 is going to try to do something bad. It's going to try to access its like a guard page below the stack. So it gets its stack pointer, it computes one page below, which is within the guard page region, tries to access that memory. And if we have set up everything correctly with our address space, this should cause a fault. And it doesn't come, in that, wow. All right, be right back. All right. Bootloader is diabolical to start with. For kernel exploitation, how deep does OS development knowledge need to be? That's actually a very interesting question, Tron. I think there are a lot of kernel exploit developers that actually don't have very deep knowledge of OS development. You need to have strong understandings of very specific parts of like the fundamentals, or maybe even not, I don't know. Like I think the thing about kernel development is you can broadly depend on the fact that the kernel like works, and then you sort of like tweak it a little bit to miss functions slightly, but I think you can actually get by without having the most strong knowledge of the fundamentals per se. So, yeah. I would agree with this, man. Yeah, I don't think you really need, and yeah, I think on the in the opposite direction. I think if you actually do have a very strong foundational understanding of OS development, I think that would make it very easy or much easier to transition into writing kernel exploits. All right, word. So let's keep it moving. I want to figure out what this compile. Right, my. So this is good. The compiler is catching some issues for me. I need to pass an address space to the idle task when it sets itself up. So now we should see a page fault or some kind of fault. Because I'm currently testing out this test 0 page fault thing. So we're gonna hopefully see page fault, good. So that means the guard page stuff is all happening correctly. Just to show, if I were to remove this, oh dang, we got a donation in the chat, it's crazy. I'll get there. If we were to quickly just remove this unmap, we are going to see a panic that says it successfully dereferenced the guard page, something is wrong. Yo, what's up, Never Rye Array? We got to add you to the board. Thank you very much for the donation. That means a lot to me. And you are now amongst the board with the other people that have donated, like James and Mohit, I'm Gods, VA80, and also James again. So thank you very much. If you donate, you get on the board. That's how it goes. So thank you very much. Never caught live. Love it. Have a coffee. I mean, thank you very much. I'm gonna hit the heart, hit the plus, hit it with a comment. Thank you. Cool. So we got this thing working. We're unmapping the guard page, or we're unmapping the guard page from the address space. I think I'll have to do one thing here. I guess there's a couple considerations, I think, actually. So to really make this work, we need to invalidate the TLB, actually, I think. There's a couple of things that are not so ideal about this. The fact is that we are it's like kind of wasteful to do this. Like we have a fixed number of task stack structures stored in a pool, and so another approach would just be on initialization time, just go through all of them and unmap all the guard pages, which frees, like makes the task not really have to do this. Maybe do this all at once on init for all guard pages. That's an idea. So this thing might go, it might leave, but as a general concept, I'm quite happy with how this task is looking at. Now we have a lot of its construction all consolidated into one place, and the consequence is that the client code in the scheduler got really cleaned up. Our construction of the idle task is just this like kind of one big unit right here. And likewise, the create task, interesting, what? My editor is sort of tripping out right now. What is going on? Why can I not do Control P anymore? Oh, maybe my keyboard ran out of battery. Holy crap. That might actually be possible. Dang, what do I do? Let me get the charger. Connected. Okay, we got power back in the keyboard. That was crazy. That's never happened to me before. Hello world, never give up, yo. What's up? Okay. I was just pointing out how good the client code looks now, and so this is now our client code. This is what it looks like to create a task. We're in the scheduler. Someone has called the create task API, and our job is to create a new task, and it's super clean. All we need to do, we allocate a task stack for the task from the pool, and then we just pass a bunch of data into this emplaceback, which constructs a new task and adds it at the end of the ETL linked list. And we just kind of bump the ID counter to give it a new ID. We set it into a runnable state. We initialize the register state in a particular way so that the task can receive an argument, like a kernel reference, for example. We're configuring them to start execution at the task func, which is the pointer that's passed here. And we also pass the p task stack, and then the address space, and then the task itself does everything it needs. It just all that's right here. So I'm happy with that. So that's just like a bit of software engineering around this. I guess I will. What's going on? Yeah, this is the patch that we did. I guess I will just sort out the Git his stuff later. Guard page, etc. Yeah. Okay. So that's looking kind of cool. I'm happy about that. And what I want to go into is more of a juicy topic. I want to get into, so this is done. Let's talk about this. Let's talk about this huge red sticky from last time. How do we destroy the task stack while we are running on it at the very end? So the problem is, let's take a look at tasks. I mean, again, we can just sort of think about what happens in this case. So the problem with my current implementation, and so we got the kernel task. It's all nice and set up. It's got its argument passed in, and then let's just say it just exits straight up. The problem is that, so when we're currently executing here, we are executing on the stack of the task, right? And we do a function call, and nothing has changed about the stack. We're still on the stack of the task that's executing. And then it's time, but the task is exiting, right? And the task is exiting, so we need to destroy it and clean up its resources. One of the resources of the stack of the task is the stack that it is running on. And so this cleanup happens right here. We call task pool.destroy. So this is that ETL. This is going into ETL, right? So this is destroy, and this is the analog function to create. And so you call create to get something from one of these pools. You call destroy to release it back to the pool. The problem is this code that's executing right in this function is executing on the stack. And we sort of like destroy the stack while we are executing on it. And that's like super sketchy. It's not good. It's not clean. It's very sketchy. How do we, yeah, what do we do about that? What's up, useless? 2 days in a row? I'm talking about streaming or what? Did I stream yesterday? I don't think I did. I also just saw that my OBS like glitched out for a second, so I hope the stream is still getting out to everyone here. Yeah, so let's talk about how to fix this. I was doing a little bit of design work on the design work on how to fix this, and stream's okay, but it cut out for 2 seconds. Yeah, dang. I occasionally experience these glitches sometimes, unfortunately, so. But good that it recovered. I have this ffmpeg command that I have now wrapped in a loop, in an infinite bash loop, just in case stuff like that happens. So it's cool that it caught it. Because one time sometimes it just like ends the stream and I don't even notice. So, yeah. So here's the idea. The idea in general of how I want to solve this is I want to do a deferred cleanup. So the idea is we're not going to just do all this stuff right here. We're going to wait until the next time we have like a safe, stable stack execution environment to run on. And then we're going to do the cleanup work. And that means both of these things. And so let's start to think about how that's going to work. So what I'm planning on doing, or just to understand how the context switch works a little bit better. So starting point is for example, right? I'll just clean up some of these files. Starting point is right here, test 0. We call task exit. We go here. We're gonna not do this stuff, but we go. But currently we clean things up. We sort of sketchily destroy the stack, even though we're on it. We unset the current task, called yield impl, which is sort of like the yield, the main body of the yield. Yield impl unsets, if there is a current task, it sets it to runnable, but not running. We choose a next, we ask the policy to choose a next task. Choose a next task from the set of possible tasks. And if it can't, it chooses the idle task, and then we switch into the next task. And that is just, that's then going into that assembly stub that sort of just like sets all the registers, jumps into the task. Why is it sketch? Are you doing too much cleaning? The reason it's sketch is because I think first there's just like a general conceptual level around of it, but then there's like some specific problems that can emerge, maybe not concretely right now, but more in the future. But just on a conceptual level, it's just sort of like our task is running, it's doing some stuff, and then it calls exit, and we we like destroy the stack and sort of release it back to the allocator. And the memory is like, technically the memory is like still kind of there, but it's just sort of weird to continue to execute code and like do function calls and like be exercising, you know, stuff on the stack when the stack has officially been like deallocated and given away to someone else potentially. So that's a bit more on a conceptual level. The real concrete, I mean, and like currently like it like kind of works actually, because just that memory just stays there. It stays writable. No one like races it in the meantime to do something. So in practice, it like kind of works, but it's very unstable. And the only thing we need to do to actually cause breakage, or like one classic thing that is coming up is adding multi-core support. And that would be something that could absolutely could break this, I think, because you could imagine that this thing is running, it's sort of in the middle of its exit, then this thing, this stack gets freed, and then while we're still running here in the scheduler, another task kind of in parallel allocates that same stack memory for itself, and then it starts doing like a bunch of stuff. And then these two stack pointers and these two tasks can potentially trample over each other. So that's my current understanding. The more I actually talk about it now, it sort of makes me, I'm actually not totally sure, because it's possible that we're going to actually have some kind of like lock, like some scheduler lock is likely what we will need. And so it might actually be possible that even if we free the memory, the scheduler is locked in such a way that no other task can try to like race and like get that stack and use it, because this thing is holding some kind of lock. But yeah, so that could be the case. So in that case, it's more on a conceptual level of just kind of just it really just does not feel proper to keep using the stack after it's been deallocated. And the stack is just one resource. There might be other resources that fall into a similar category where we're sort of like using them up until like really the last moment, and it's sort of unsafe to like deallocate them like live as we're kind of running. And so the safer option is to just simply wait until we've chosen the next task. We're in a stable, safe execution point on a different stack, and then sort of go back and clean up a lot of the remaining stuff from the previous task. I should say that this is really pushing the edge of my knowledge in this area, and so if you have reasons to question or challenge me, I'm absolutely open to that. This is my current understanding. And whether or not I'm right or wrong, it's interesting to explore these ideas. And that's exactly sort of the whole purpose of writing the custom OS, is so we can play around. And so the idea is, let's check out yield impl. And so, like I said, the idea is to wait until the point where a next task is chosen. Maybe I'll just sort of like write some of these ideas down. So So problem, we dealloc the stack, but then keep using it. We keep running the scheduler itself on a deallocated stack. This kind of sketchily works in practice, but feels like bad form and could potentially break down with multi-core support. So, solution. We try a deferred approach. Wait until the next task is chosen and we've and its stack is known. Execute some cleanup code before jumping into the next task. Execute that cleanup code on the stack of the new task. That's the idea. Yeah. All right. I'm gonna take a very short break. I'm gonna go. Wait, can I edit the break? Break for 3 seconds. All right, I can't figure this out. Give me a second. I'm going to take a very short break. I'll be right back in maybe 1 or 2 minutes. Word. All right. We got some chat activity going on. Parallel lanes. Task runs in lane 1. User event task runs in lane 2. Never touch. Seems awareness. Why not 3 task lists, scheduled, running, and exited? Then once your task is exited, interesting. I'm gonna screenshot some of these ideas. I think really what we're getting into and what we're seeing here is that there's different ways to do things. And these are just genuinely different approaches. Call it Ray's solution. So Ray is proposing an idea where the task just gets marked as exited, and then you can remove it later. I think that's like actually a little bit similar to what we're doing here, but I think the question here is just then like, who and like when is that exited task going to get cleaned up? I think that's the main difference here. What I'm proposing is we sort of do it like soon, like right on the next task transition. We just immediately clean up the previous task. And what I understand from this is sort of like, it's a little bit more deferred, and we can, yeah, maybe there's some like other task whose job is like to clean up all of these exited tasks. I mean, I think really what this sounds like, it sounds like a zombie idea. You know, you hear about zombie processes on Linux and stuff like this. It sounds like this exited task is sort of like a zombie state. And I think, yeah, that's something I want to learn about. I think there's good reasons to introduce zombie states. And at the same time, I think if you can avoid a zombie state, that might be kind of nice. So I think just for the moment, I want to try just exploring this idea. What's up, Asans? All right, so here's the idea. Let's try to implement it. And so the first thing we need to figure out is when is the next task chosen, and at what point is the stack kind of like stable where we can run some arbitrary code on the stack of the next task. So that would be the first thing we need to figure out. And the answer is, so here's where the next task is chosen. And switch to task is basically one of the last parts of the scheduler that runs. It sets some state within the scheduler, like the pointer to the current task. It sets the task to be in a running state. We just do some basic assertions, and then we go into restore right here. And so at some point we need to figure out how we are going to kind of inject a cleanup phase into here. So what we want to do is we want to switch stacks onto the stack of the next task. This is kind of interesting because let's think about back to our memory diagram. Let's say there's two tasks, each with their own stacks, right? So this is task 1, this is task 2, and task 1 is the one that's exiting right now. So it's doing some stuff, it did some function calls, and now it's out. It's time to go. So what we want to do, so this thing stays around, right? The stack does not immediately get deallocated in the process of calling the exit API. This thing stays around, but then we go over here and we're like, okay, this is going to be the task that starts running. And very specifically, okay, I wanted to make a line. L? Line. Okay. Very specifically, like that line, I know it's kind of crooked, but this line is where it's sort of the frozen stack pointer state of this task. And what I'm proposing to do is, like, this thing is sort of in a frozen state right now. It has a bunch of stack stuff up here that we can't touch. But what I'm proposing to do is we switch stacks to point to right here. And we enter, and we run some, like, I'm gonna use the pen tool. We like run a bunch of arbitrary code below here for a little bit. And then that code is going to return, it's going to come up to the exact same spot, and then we're going to flip and resume this task, which never even knew that we actually ran a bunch of code on its stack. So yes, switching the stack for fun and profit. Yes, so let's flesh this out. I think the way it's going to work is this. So first thing we need to do, it's like we need a couple components here. We need to switch the stack at a certain point, and then we need a function that gets called after the stack switch. So the flow is going to look something like this. So we're going to have a couple components, like we do the stack switch. We're going to call or jump into scheduler deferred cleanup routine. And then when the scheduler deferred cleanup routine is finished, it's just going to hard restore into the task. And by hard restore, I mean like this sm sched restore task, which just like, it just sort of like brute forces like jumping into a task. It just like takes the register states, kind of like slams them all into place and just like jumps into the task in a sort of just like very like raw way. And so that's what this deferred routine is going to do when it's finished with its work and it is time to like really enter the task. So I'm going to try something out. I'm just going to try to inject some code right here, potentially. And so the thing is also, this code is going to, the code here in switch to task is going to need knowledge of the task that needs to be cleaned up, actually. And so that's also a question. And I think a simple answer is just simply to pass it through these function calls potentially. And so let's try this. And so I'm going to comment these out. We still do want to set the current task to null pointer, but what I'm going to do, I see. Maybe what I'll do is old task equals, there we go. I'm gonna call it the old task. Or like something like task to be cleaned up. We're going to pass this into yield impl. And now we're going to change this. No, it's going to be a task. And maybe it is defaulted to be a null pointer. So wall markets, is it a way of meditation for you, writing nothing going out live? Yeah, a little bit. I would say a form of meditation makes sense. Growing a bonsai tree, yeah. Yeah, exactly. This is my bonsai tree. Look at how beautiful it is. Look at how small it is. So we're going to take this task, we're going to pass it into the yield impl. And then we are just going to pass it through here. P task to be cleaned up. And then this thing receives the P task to be cleaned up. And that's interesting. And so maybe, yes, then maybe there's not necessarily always a task to be cleaned up when we are doing a yield. Also curious about one thing. Okay. The other caller of yield impl is start. So just the very, very, very start of like everything. At that point, there's no previous task to clean up, and so let's just keep going, because it's week 115. It's obvious you have 1,000 more weeks to do something meaningful with your OS. Dude, 1,000? You have a lot of confidence in me. I was thinking more like 10,000 or something like that. So yeah, so we got the tasks to be cleaned up. And then now it's like, okay, what do we do with that? Let's say there's no task. So if I'm going to snooze the inline suggestions for 5 minutes so I can try to use my brain a little bit. So if we don't have, we're just going to go straight into here, I think. Panic unreachable. And then what's the deal here? If we do have a task to be cleaned up, we need to set swap stack pointer. There's a heads up, 10,000 weeks is like 191 years. Oh, is that the case? Is that the case? Well, then we just need to really hope that all that kind of cybernetics stuff comes out pretty soon to give me the time I need. So a swap stack pointer into, and so here we totally know the next task. It's right here. We can even call it next, or I don't know. It's like, this is the task to switch to, right? It's like, we can call it new task. We're going to switch. We totally know new tasks RSP. It's in the register state. So we can swap into it and then call a method or a function which will always end in this. So let's think a little bit. Let's assume just need to make an AI clone of yourself to finish the work. What's up, Shivam? Why did I make this? I made it to learn how operating systems work, and just to make something that I can be proud of, and just kind of test myself, just kind of see what I'm capable of, test my skills, that kind of thing. So let's sort of like defer this particular point for now, swapping the stack point. Let's assume we already had a function. I'm just gonna sketch like another private method. That's where we are. We're in the private section. So I'm just gonna call it void deferred cleanup. Yeah, what projects is everyone working on? Feel free to pop that or post about what you're working on. So we're gonna swap the stack pointer, and then we're gonna call deferred cleanup. I mean, it might. I mean, yeah, I think it is necessary to sort of initiate a fresh function call if we. Yeah, I mean, okay. That's a question for the chat to test your knowledge. Why? Like, if we just set the stack pointer but then kept executing code in this function, why or why not is that safe? Or is there a reason why we might need to specifically call into a new function if we do something like swapping the stack pointer. So the reason, we can think about it a little bit. So what we're doing is a little bit extreme. It's kind of unusual, right? Running code in the scheduler on the task of stack 1. And yeah, we're like running code on a stack frame over here. Like this is a stack, and we have like a stack frame for this scheduler stuff that we're doing. And then we are like kind of just very abruptly forcing the stack pointer to be in a completely different location. This might even be an interesting time to check out what the disassembly looks like. Just as it sort of helps a little bit. And so if we take a look at the scheduler switch to task, for example, scheduler switch to task, we can see that yeah, it's like RSP blah 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 blah. This might be another case where it might actually work, but it is super sketchy. In general, so going back to more of an intuitive conceptual argument for why it would be bad to keep executing code in the function after forcibly changing the stack pointer, the compiler, when it's emitting and generating the code, it is assuming that it's the only one doing things with the stack pointer. That's what it's assuming when it's generating. It's assuming that the code is basically just kind of just like flowing from top to bottom, and nothing, and the stack pointer is not being altered by some like weird external source. And if we alter it and reset it somewhere, that is going to violate some assumptions. And it's not particularly relevant in our case, but I'll kill the poverty since we're getting close to the end of time. Imagine if the function tried to return. The compiler is assuming that there is like that there's some kind of return address pushed somewhere over here, and assuming that we're gonna to push stuff on the stack, and then things are going to pop. Kind of. It's assuming that it's going to. This is kind of a bad example because it's such a weird function which is doing all this assembly stuff. In normal cases, you have a add RSP at the end. And so the compiler is inserting code that at the start of the function, it drops RSP quite a bit to allocate stack frame. At the very end, it pushes up RSP quite a bit to clean everything up. It's assuming that it's in control of everything. And so yeah, it would violate that assumption. And I was thinking about local stack variables. And so local stack variables are referenced via an RBP offset. And so actually those would continue to work. Even if you sort of like are executing code here, you rip RSP to point over here, our BP is like still pointed over here. And so local variable references will continue to work. But yeah, like imagine what if you tried to call another, yeah, what if you were over here, swapped the stack pointer and tried to call some other functions and like return from those functions. Calling and returning assumes like some kind of contiguity of the stack, but the stack is sort of like weirdly broken. I'm gonna shut up. I'm just gonna code. So we're gonna swap the stack pointer in a moment, and then hit a fresh execution context in deferred cleanup, which will never be returned from. So we're gonna, and in the deferred cleanup is going to need a few things. It's going to need to know the P task to be cleaned up, of course, and it's also going to need to know the new task to enter. And so we're going to need task. And here's the part where I copy and paste the code over here. So instead of MP current task, it's P task to be cleaned up. Oh dang, what? Right. And it's fun. It's a lot of talking. It's not a lot of code. And then this comes here. And this is how I'm thinking that it's going to work. Yes, and so I think the final part is like, how do we actually swap the stack point? It's going to require some inline assembly. And as usual, I will probably ask the AI. We have a function called read RSP, but that's not what we want. We want something that's sort of like a write RSP. We want to be able to like set the RSP. So I'm going to vibe code a single function for setting the RSP. Good. It's like, how would you, like, I don't know if, also, is this in, wait, I could have sworn we ported things to AT&T syntax, but I'm seeing a lot of ampersands, or percent signs, so. Unfortunately, we are still in AT&T syntax mode in this file. But yeah, so in readsp, wait, you know what, actually I'm not totally sure. Because Intel syntax goes from right into the left thing, and that sort of matches. So I think we actually are in Intel syntax, but maybe it's the inline assembly syntax which requires the percent sign. So what I'm going to do, now that I have my fancy function for write RSP, I'm going to call it RSP, and we're going to do that. And now that means I'm going to have to depend on x86.h for the first time in this file. And that's kind of it. Yeah, before I even try to run this, I actually really want to look at the assembly to verify what's happening, because this is a pretty delicate operation, and it's for things like this, it's important to know really what's going on. And so we're in switch to task. And let's make it nice and comfortable to read. Just get it all right next to each other. Oh damn, we got 51 people in the chat. What up, chat? And then we're going to go over here, just screenshot a little bit of what's going on over here. What's up, Rahul? You're a suburb of thank you, Shivam. Martian Coder, this is awesome. Thank you. Aren't you using Claude AI or CLI to do this quick? I use it sometimes. Where binary ninja usage? 96. Okay. So this is pretty much what we're working with. So let's say someone was in a job interview and they were like, look at this hobby OS code that some random YouTuber wrote. Is it correct or not? How would you answer that question? Here's a binary ninja. Here's some code. Is it correct or not? What do you answer? Let's check it out. Where do I work? I work in the music tech industry on a hardware product. So let's just sort of map out, let's just see if we can identify this C++ code in the assembly. And so let's look out for like the asserts and this if statement, right? So the asserts are kind of easy to identify because this code actually gets emitted as strings in the binary, and we can see them right here. And so call assert failed impl 1 and 2. RSP not equal to 0, rip not equal to 0. And so this is what the assert looks like expanded out into assembly. After the macro is expanded. And so what I'm specifically looking for is I want to look at this write RSP thing and see what it looks like. And so this is the second assert. Now I want to find the if statement. What does this look like? If p task to be cleaned up. And I will note that binary ninja is like super fancy and there are ways to see a higher level view, and I kind of don't want to use that because I think it's important to not depend on tools like that. What I'm actually seeing though is I think this is showing that I forgot to recompile, or so the job interview was a trick question. Let me just screenshot that. I forgot to recompile. Okay. Now let's reopen binary ninja. Switch to, okay. And just to cheat a little bit, yeah. So you can immediately see it's like kind of different because I forgot to recompile. And so we are missing some very important things here, like the if statement. And to be honest, I wasn't seeing it. I was like, okay, we have the assert and there's not that much code here. We call it call the SM schedule restore task and then the panic. And so jumping back into the assembly, now let's get that here. So this is really what things are supposed to look like. I forgot what instruction is an if statement. I'll give you a hint. it's a very pixelated version of this. CMP. If statements are a combination of two instructions, usually compare and then a conditional jump of some kind. And so that's what we're seeing here. And so yeah, let's just read it, sort of compare blah 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 jump here. And so we don't need to read every single line, but just this notion that there's like compare, a jump, and then there was the call to the asm sched restore task plus the panic. And so that's this chunk right here is looking very suspiciously close to what we're seeing over here, basically. So that's the if. And then yeah, I'm super zoned in on this what the right RSP looks like, because that's a very something you don't really do every day. Interesting. Interesting. So this is already not really what I want to see. Ray, I thought jump was jump in assembly. Is JNE something similar? JNE is jump if not equal. And it's a conditional jump. I think you're correct that unconditional jumps are just normal jump. It's just like, that's just always going to jump to someplace. This is a conditional jump. So I'm glad I looked at this, because this is already not what I want to see. It's a function call. And yeah, this is kind of whack. It's a function call that sets RSP but then returns, and that is not, this is not what I want. I just want a very, very surgical, like almost a single instruction sort of thing. So protocol backend. Oh man, the chatbot police popped in. Please refrain from spamming caps. Yeah, someone said a slur in the chat last week, which is why I have added the police bot, and we're seeing some of its guard attempts right now. Yeah, maybe I can tweak that later. Okay, so I don't want to see a function call. Please refrain from spamming symbols. Oh man, the chat police is going kind of crazy. Okay, I might tell the chat police to chill a little bit. So I feel like it's being a little bit heavy-handed right now. I'll relax some of these rules. If you want to go ahead and send a message with 20 question marks, you can now do so. So the problem is, no, it's all right. Static inline. It's interesting that this did not get inlined. In the inline keyword, it does not guarantee that something is inline. I mean, really, the inline keyword is more needed if you are going to have a function definition, or definition that's in a header file in the first place. And so that's sort of like the first meaning around it. It's like this sort of linkage related term. Secondly, I think it has possibly some impact on like actual inlining, but and how do we get a single line to 5 different ones? That's a great question. Ismail's wondering, like, what's the deal? We had a single line of code here, and then why? Well, like, why is it like all these lines of code? Because this, the compiler doesn't necessarily know that we didn't want all of that excess prologue and epilogue code. So it just does its normal thing. It just sort of does its normal setup and destruction of the stack frame, and then it's like, okay, what did you want inside there? You wanted a move RSP. All right, it just pops that in there, and that's it. So that's a little bit disappointing. Just to move forward, I'm just going to not do the function. I'm just going to inline this very directly, which I really don't love. It would be really nice to maybe I can ask the AI, make this a naked function. There's this like naked function concept where you can actually specifically request that the compiler removes like the prologue and epilogue junk that's at the start and end of a function by default. If you really want to not have it. So this is sort of interesting now. So it has sort of vibe coded. Actually, should I did, wait. Now it's made a naked function. I'm just curious to see what this compiles to. Let's build again and look one more time at the assembly. Switch to. Yeah. While I see that there's a bunch of people in the chat, there's 44 people in the chat, I want to quickly give a shout out to my sponsor, Let's Get Rusty, because I sort of did this earlier in the stream. But yeah, they have been sponsoring me recently to stream actually, which is really nice of them. They are offering trainings and job placement for Rust programming. They do cohorts every month. And so they have been really great to work with and are sponsoring my streams, which is awesome. And if you are interested in that, you can use my link, Start with Mark, to yeah, like explore their options for Rust training. So yeah, I appreciate that a lot, and feel free to show them some love if that's all at all aligned with something that you are interested in. All right. Anyway, yeah, it's sort of a new thing, new thing, and I'm excited just to have a bit of sponsor support for what I'm doing here, which is pretty cool. So let's take a look at Binary Ninja now. So what happened? Okay, so we still have a function call, which is not amazing. But let's take a look inside, and this is what it looks like now. So, and this is maybe a little bit more intuitive for what we might have expected, given that there was just the single assembly instruction thing, but this is still not what we want. Basically, I want this line and only this line to appear basically like right here. I really do not want to be executing any other instructions other than setting the stack pointer. This is a pretty cool part of OS stuff. It's really not every day or every moment where we get to be so surgical with the manipulation of the registers and the execution environment. This is also something you very rarely encounter in like normal user space programming, unless you are implementing user space threads or like something like very OS-like in user space. This is a pretty unique moment, and so I'm pretty happy to be getting the chance to play with it. And so yeah, and so for the moment, this is what we need to do. I think I really just want to force the compiler to really just seriously put only a single instruction there, and it's going to be new task. It's going to be this thing. This is what we're passing into there. Maybe, okay, what's up, Sarab? Maybe volatile is disallowing compiler to optimize the call. Interesting. So you're saying that maybe like the fact that there was maybe a volatile here could it be impacting that? That's interesting. Actually, honestly, I have no idea what volatile means when used after an assembly, an inline assembly thing. For the moment, just to move forward with this, like right now, I'm just gonna inline this just to force the compiler to really do that. And let's take a look at how this looks. Okay. Okay, remember, this is a job interview. Someone is asking you to code review some random code that a YouTuber wrote and see if it's good or not. So be ready for this in your next job interview. Okay, so what is going on here? So things look a little bit different, right? Things are looking a little bit different. And what changed? So what changed is, check it out. There's no more function call to write RSP, like obviously because we removed it. We were seeing that all the time before here. Instead, we have pretty much something like super surgical. It is like kind of pushing racks into RSP, resetting our RSP to point at racks. And it's not like super obvious what racks is, but racks is, racks is just going to be the RSP value that's stored in the task state of register. Yeah. Right. Volatile copies the memory state in case it changes elsewhere. That's, I mean, the thing is, volatile has different meanings. Volatile has has one meaning when you declare a variable as volatile, or like a pointer as volatile, that forces the compiler to always emit memory references and never locally cache things in a register. And maybe I'm wrong, but I wonder if the volatile here could possibly have a different meaning. It's honestly not super important because we have what we need. This is exactly what I want. I want a single, like, surgical move RSP instruction followed very shortly by a function call. And that's what we got. So I think we're pretty much, we are like, yeah, we're basically done. I think we can try to run it, and what we'll just do is we'll just step through it in the debugger just to really verify the stack and everything like that. And that will be the last thing we do today. So, but yeah, we need to set up a test environment. So what's our kernel? What's CPP looking at? So we have our test 0, cool. And what do we want to happen? And so let's say we want to have, well, okay, we're just gonna have test 0 task that exits, and then it's going to call into the idle task. And that should be totally fine. So I mean, yeah, let's just go for it. So I think this totally works, and so I'm just going to start debugging. Okay, we're gonna break on test 0. All right, so we're right here. Our kernel task is running. It has been scheduled as the only task on the system apart from the idle task. We are about to enter task exit. And we're in there. We're doing some stuff. Did it crash? Oh, what? Our assertion failed. What? Oh, interesting. I think I may have slightly broke. It's saying the idle task should never exit, aka the task with task 0. But this is test 1. Wait, I'm just going to print current task ID. Can it do that? Okay. It knows how to do this, so let's just run that one more time. That was weird. Why is test 0 task number 0? Something is wrong. Interesting. What the? I'm gonna add, do we have a logging? I was gonna add, yeah, I guess what the, I'm confused about the, how did test 0 get task ID 0? Let's just create task ID counter. Oh, I think that's the problem. Okay, yeah. Create task is using task ID counter, which gets initialized to 0, but the idle task actually doesn't use that, and so this should be idle task ID counter ++. Okay. This thing needs to come early then. What's up, Ogata? Can you show the OS UI? There is no UI. This is the OS so far. It's just it's kind of a baby OS, so we don't really have fancy things like a UI. Yes, so that was a bug in my previous refactor. I wasn't constructing the tasks appropriately, and so so both the idle task and tasks test 0 were getting assigned the task ID 0 for the idle task, which goes to show you why it's good to have asserts in your program. Because otherwise I would not have caught that bug for some time. I think that's like a little bit of a subtle thing. So shout out asserts. Okay, let's run it again. We're gonna break on test 0. We're going to we're going to come over here. And we're going to step into yield impl. And we're over here. And we are, okay, so the policy should not have been able to find a next task because test 0 is the only task on the system and that just exited. Or is that true? So the way, let's just verify that really quickly, because right, task exit. It's, yeah, okay, wait, so how does this work again? The policy chooses a next task, and it's just looking for a runnable task. I see. So actually, I think that's a bug. Formerly, this was working because we were removing, like in this task exit, we were calling this erase function. We were calling this thing in the task exit, which runs before the scheduler. And so then the scheduler like basically just doesn't see any tasks in the list. It receives an empty list and it sees nothing. And what has happened here, and I think this is to Ray's point. I think currently, since we have not erased it yet, the scheduler just is going to see a list with one thing in it, which is the task that previously was destroyed, but it's just sitting in that. And so my prediction is that actually p next task is going to have a value. But obviously I'm wrong. What? And why? Okay, let's do that a little bit more slowly. This is interesting enough to dive into. Okay, so break test 0. You can never really know what's going on. Okay, well, just for documentation purposes. Task. Okay. A090. That is the test 0. Are you destroying the wrong task list? There's only one task list, so I don't have multiple lists yet. So let's oh wait, I see. Let me step. Here's why. Okay, here's why. No, the problem, okay, wow, that was confusing. Or what? This is crazy. So MP current task no longer has a value. Task exit is not doing so much anymore, but what it is doing is it's unsetting the current task pointer within the scheduler. The scheduler's notion of like the current task. And so that's no longer there. And then MP task gets passed into here. So that's passing a null pointer, but the thing is M tasks should still have something in it. And let's see, P tasks. The bad thing about C++ generic data structures is that you can't, like, printing them is like kind of useless. But I'm going to predict that the tasks is not empty. Yeah, the tasks are not empty. There is one thing in the task list. I just want to print that out. Log. Choosing next. Okay, I don't, yeah. Choosing next task among next tasks. I'm just gonna break on yield. Oh my gosh. Okay, we're going to step in here. Yeah, among one task. So there is definitely one task that's still in the list. And it's returning a pointer to it. What is going on? Why? Okay. I wonder, wait, did I forget to actually execute this thing? Okay. It gets a task. And so I think there's legitimately a bug here. Yeah. Like the scheduler just sort of like, we didn't remove that thing from the list. The scheduler just sees the list. The thing should have exited, but we don't have a state for that yet. And that's exactly what Ray was proposing. And so now what's going to happen is we're going to switch. That's crazy. We're going to switch back into the task, but also like destroy it, I think. Because now we're passing p next task and p task to be cleaned up, and they are the same pointer. This is bad. And yeah, okay, I don't know. That I hit next instead of step, and that was like kind of weird. What we need to do is we need to, I'm pretty sure we need to add the exited state that Ray was saying. What I want to do is I want to assert that p task. Wait, you know, this could actually be a reference. Sorry, that's like a little bit of like a and then yeah, sorry. Let's see if this assert fires. I actually think this assert will fire. Wow. Something is super confusing about that situation. Or wait a sec, what? Wait. Okay, wow. I was a lot more confident than I thought. This is quite different. Let's slow down like a little bit. I'm pretty sure we are close. So we're coming in here. We're coming in here. The A09, we're going to step in here. We're going to step into the policy. The policy says that there's one task remaining, which makes sense. It's the test 0 thing. We're going to come in here and test cleanup right now. Maybe Ray is faster than me right now. What? Wait, why was it a null pointer? I'm setting the null pointer, I think, in exactly one place. Right. I'm setting MP current task to null pointer. The state of the task list is unchanged. So we're going, the thing has one thing in it. So we're going to get an iterator to the current task. We're going to increment it, which will make it be the end. And then that's going to cause this to make it be the beginning, which points it back at itself. Start is going to point at this at the begin. And that should be, I'm going to add some more prints, I think. I'm going to add log print the adder of the task. We're checking task ID and its address. Oops. Okay, this is useless because it's apparently running super fast. Okay. Btest 0. Among one task, we're choosing among one task. Cool. We're checking task 1. Oh, wait. That's so weird. It didn't hit this because the task is in a currently running state. And this thing only checks if we're looking for runnable tasks. And that's why it returns a null pointer. Okay. That's why it returned a null pointer. Whoa. Whoa, is the chat still there? My YouTube tab crashed in my browser just now. That's crazy. Am I still live? That's freaking wild. My browser literally crashed the tab. Okay, sorry. Bad. So, right, the task is literally running still. So, anyway, that's actually why. That's actually, I think things worked in a weird way. Okay, well, it's just like, I'm gonna stop effing around and I'm just gonna fix this. So what I'm gonna do is I'm gonna do Ray's suggestion. We're gonna add a state, a sketch state. Currently we have runnable, running, not runnable, which is not currently used. And I'm gonna say we're gonna, exited. Sounds like a good one. And we're going to set mempy current task to exited. And that, And then the question is, why do we do that? We're going to do that so that the next time the policy comes around, our thing is still in the task list at the moment, but we want it just to not have a runnable state. And then we want it to have we also want it to have a sane state. And so it's sort of insane to have it be in a running state. And so we just need some kind of state. And so it's going to be in an exited state. And so that is going to come over here. Okay, I think we're going to be in a bit more of a working place right now. Pop in the debugger. And I got to get my debugging set up like a little bit better. It's like cumbersome, just like these breakpoints all the time. But okay, so we're here. Current task sched state is exited. Okay, cool. We're going to jump into the yield impl. We don't have a current task because we literally just we literally just nulled it out, so we're not going to do that. We're going to jump into the policy reports that we have one task to search through. We are coming over here, and we have let's see. Does this work? I cannot evaluate this, unfortunately. So it's not really important. What is important is that we're going to drop out of the loop and hit the return null pointer. So there's one thing in the list. It's our exited state. Our exited state is not runnable not in a runnable state, and so we just didn't find anything, and the scheduler bails out and says I could not find anything to run. We return the null pointer, which means we set the next task to be the idle task, and we switch into it. We set the MP current task to point to the idle task. We set the idle task to be in a running state. We assert some registers. And then here's the new code. P task to be cleaned up. And so let's just sanity check this. That's exactly what we're seeing. The A090, that's exactly the task we want to be cleaned up. And so we're going to not enter the if statement. And here's the spicy part where things are going to get super interesting. We're going to switch the stack onto the stack pointer of the idle task, and then run the deferred cleanup. And so let's just like really verify this at the assembly level. So we were looking in Binary Ninja earlier. This is exactly the code we were looking at. Let's just verify a couple things. So let's just verify our current stack pointer. All right, this is like weird output, but like D1F. That's how you read it. That's how you read it, right? Okay. The DF30. Right. So that's our current stack pointer. We're still running on the test 0 task, which is the one we're trying to destroy. And we're trying to like get off of that stack. And so let's also take a look at what is its new task.registerstate.rsp. Let's take a look at that in hex. 25FF8. So I'm going to step a couple instructions. Eyes over here. Okay, here we are. We're lined up right on the instruction. PX racks. It should be this 25FF8. Perfect. And literally, we're just going to like swap the stack. And so I'm going to step one more instruction and RSP. So RSP, just like we expected, is now on this new stack. And I see that NSG is in the chat, which is awesome. because we can ask NSG how he does his task cleanup, and how does he handle it when a task is getting destroyed while it's like running on the task stack. So we haven't done it quite yet, but we're like very, very close. And so now what's left to do is we're going to call into the deferred cleanup on the idle threads stack, or on the idle tasks stack. And that's like the hardcore, that's like the cool and hardcore part about this. Like the scheduler like doesn't care, like the scheduler doesn't like give a F like who's, if it's your stack, it's like it's gonna run code on whoever's stack it feels like. And so the scheduler is like hardcore and can do stuff like this. And so the scheduler is about to we're gonna call into this. And so again, looking at RSP, it hasn't changed. Now we're on this different stack. We're gonna call into this routine onto the idle thread stack. And now we're over here. Yeah, and we are running, we are running code on the new threads, on the idle threads stack, and we're we are running our assertion. And here we are, and here's the cool part. Now we're about to clean everything up, and we're doing so from a very safe place. We're cleaning up, like we are pretty firmly on the new stack of the idle task, and we can very safely destroy the stack of the one that we're cleaning up on the other end. And so I guess it's not, I don't know how climactic that is, but now we're going ahead and we are okay, NSG, the way I clean up is wrong since it frees the kernel stack while running on it, so I should probably fix that ASAP. Okay, got you. Cool. So that's exactly what we've been working on right now. It's sort of like, how do we more safely handle that situation? And the way we've like been pair programming this right now is we wait until the next task has been scheduled and then run a deferred cleanup routine on the stack of the new task, which then can safely do whatever it needs to do. So stream is freezing quite a bit. Oh, bummer. I don't know why that is. I'm sorry about that. Yeah, I'm also gonna restart the music. It's been about 3 hours. Okay, hopefully I'm coming through relatively clearly. Yeah, anyway. And also NSG, are you, just to clarify, are you talking about Polaris or your own new fancy and very secretive kernel? Okay, cool. So just to kind of wrap up this explanation, we've just destroyed the task in a safe way. We have also erased the task from the linked list. And so now the linked list should have 0 things in it. But now here's the part where we're heading into SM sched restore task, and we're about to enter the idle task, and we return and check it out. We are actually entering the beginning of the idle task, since it actually never had code execution yet at all on the system. And so yeah, I guess your FFmpeg script is doing heavy work. Yeah, like I gotta check my FFmpeg script. What is it doing? Okay, so this thing is looking good. And now, just to like really wrap everything up, the last thing I want to show is let's check out the scheduler like logging when it prints out how many tasks there are on the system. So now the idle task has just yielded to the scheduler. This is all happening after the deferred cleanup happened, and so we should like legit have 0 tasks in the task list, and that's what we see. 0 tasks in the task list. And that indicates that we are successfully on the other side. And I'm going to give us all a big ass star for doing that. So solid. Yeah, so at this point the scheduler is returning. It's just hitting if the task list is empty, there's just nothing to run, and so it returns a null pointer, at which point the scheduler sees that and then selects the idle task again. And right now, it's sort of like the idle task switching back into the idle task, and our P task to be cleaned up is null pointer because we're not engaging this kind of thing. So that's sick. Stream went kind of long today, but we've just been having way too much fun. And got 54 people in the chat. I think I saw a question from you, NSG, about like locks and stuff. I have 0 locks. I have zero locks, 0 concurrency, 0 mutexes. Like that's all coming pretty shortly. I think my roadmap is that. So this like phase 1 of the scheduler work is coming along quite well. It's pretty much done, I guess. Like we can yield and we can exit in a clean way. And I think we are kind of getting ready to move on to the next phase, which would be preemptive scheduling, which is finally adding that timer tick. And that is the first phase of the project where locks become relevant. Because that's once we start adding preemptive scheduling, that's where tasks can interleave each other. Currently, there's no interleaving possible because it's all cooperative, and so we'll add a spin lock as soon as we get some of that preemptive interleaving going. So that's going to wrap it up. I think just to close out the stream, just one more time, I'm just going to thank my sponsor. Big thank you to Let's Get Rusty for sponsoring these streams. You can use my link, start with Mark, if you are interested in learning Rust in a kind of environment with mentors and stuff like that. And I also want to say that I am personally working on my own course, actually. I've been getting a lot of requests about how to learn programming and stuff like this. And so I'm personally starting to work on the beginnings of my own course. And if you're interested to hear about that more, you can sign up for my newsletter. Yeah, and I think, yeah, Rust sponsors C++ dev. Yeah, somehow I finagled that. So I got a Rust sponsor on my C++ dev stream. Imagine that. All right, well, let's wrap it up. If you like this content, please subscribe to my channel. feel free to join us in the Discord. I hope you have a great week. I hope you pass all of your job interviews coming up where they ask you to code review buggy code that was written by YouTubers. And I'll see you in the next one. Have a great week, everyone. I'll catch you later. Peace.